Hey everyone! Welcome to SyntaxGrid. Today we're building a powerful sentiment analysis model using Naïve Bayes. We'll cover data pre-processing, feature extraction, model training, hyperparameter tuning, and evaluation. Before diving into the implementation, make sure to check out my previous video, where I explain the full concepts of Naïve Bayes in detail. We are building a sentiment analysis model using the IMDb dataset. The goal is to classify movie reviews as either positive or negative using Naïve Bayes. This project involves 1. Loading and cleaning the dataset. 2. Pre-processing text, removing noise, stop words, stemming. 3. Converting text into numerical form using TF-IDF. 4. Training a multinomial Naïve Bayes model. 5. Evaluating performance. 6. Hyperparameter tuning. 7. Testing with new reviews. Let's get started. Step 1. Load and inspect the dataset. Before building a model, we need to understand the data. We check its size, structure, and quality to decide on the necessary pre-processing steps. The IMDb dataset contains movie reviews, text, and their corresponding sentiments, labels positive or negative. We use pandas to load the dataset. Checking missing values and duplicates ensures that our data is clean. Step 2. Sentiment, distribution, visualization. We need to check whether our dataset is balanced. If one sentiment, positive-negative, is significantly more than the other, the model might become biased. We use Seaborn to create a bar chart of the sentiment distribution. If there are more positive reviews than negative ones, the model may favor predicting positive reviews. If the data is highly imbalanced, we may need data balancing techniques. Example, undersampling or oversampling. Step 3. Converting sentiments to numerical labels. Machine learning models work with numbers, not text. We need to convert positive to 1, negative to 0. Mapping sentiment labels helps the model understand the classification task. Without this step, the algorithm cannot process the data. Step 4. Text pre-processing. Raw text contains noise like HTML tags, punctuation, stop words, and capitalization. Cleaning improves model performance by removing unnecessary elements. Pre-processing steps. 1. Removing HTML tags. 2. Removing special characters. 3. Converting to lowercase. 4. Tokenization. 5. Removing stop words. 6. Stemming. Step 5. Convert text into features, TF-IDF. ML models cannot understand text directly. We must convert words into numerical representations. What is TF-IDF? TF-IDF, term frequency, inverse document frequency, converts text into numerical features based on TF, term frequency, how often a word appears in a review. IDF, inverse document frequency, how unique a word is across all reviews. Why TF-IDF instead of bag of words? TF-IDF gives importance to meaningful words while ignoring common words. Example, if movie appears in 90% of reviews, it is not useful. If masterpiece appears in only 5%, it is important. Step 6. Splitting data for training and testing. We must evaluate the model's performance on unseen data. 80% of the dataset is used for training. 20% is used for testing to check accuracy. If we train on 100% of the data, the model will memorize it instead of generalizing. A good train-test split ensures that the model learns patterns without overfitting. Step 7. Train the Naïve Bayes model. We use multinomial Naïve Bayes, which is well suited for text classification. Naïve Bayes assumes words are independent, meaning the probability of one word appearing doesn't affect another. It works well even with small datasets and is very fast. Step 8. Evaluate model performance. We need to measure accuracy to see how well the model performs. Accuracy score, percentage of correct predictions, confusion matrix, true positives, TP, correctly predicted positive reviews, true negatives, TN, correctly predicted negative reviews, false positives, FP, predicted positive, but it was negative, precision, recall, F1 score, more detailed performance metrics. Step 9. Hyperparameter tuning. Adjusting hyperparameters improves model accuracy. We tune alpha, smoothing parameter, to prevent zero probabilities. Using grid search CV, we find the best alpha value for the model. Why is alpha important? If a word never appears in negative reviews, its probability will be 0. Step 10. Test on new reviews. Testing on new, unseen data ensures the model generalizes well. We provide 2 sample reviews, one positive and one negative. The model predicts their sentiment. This helps verify whether it works in a real-world scenario. That's it. We successfully built and optimized a Naïve Bayes sentiment classifier. If you found this helpful, smash the like button, subscribe, and hit the bell icon for more awesome content.